We know that carbon going into our atmosphere has increased through time since the Industrial Revolution. Now let's look into the future and think what can be done about this. So if we take climate and carbon cycle feedback loops into account, like we've been talking about before, we can quantify how fossil fuel emissions will look in the future and how they're competitive with the representative concentration pathways, right? These are the RCP scenarios. Basically, you think about, worst case scenario, 8.5, best case scenario, 2.6, and it all depends on our actions. We can choose which scenario we want to go down. So the plot we're showing here, the black is observed, and the colors are what was projected into the future based on human actions. This plot, the observations stop just after 2000. So I am going to add where we are right now so we can see what pathway we're on. In 2021, we released almost 10 petagrams of carbon. And you can see this puts us around the middle, right? We're not on the worst trajectory. We're also not on the best trajectory. We're right around RCP 4.5 to 6, right? So right, we have the steps that we have made a difference, right? It could be worse. This shows that human actions are making a difference. However, it also shows that we could be doing a lot more. Okay. And we need to be doing a lot more because the more and more carbon that's in our atmosphere, the longer and longer it's going to take for the Earth to be able to go back to normal. So we talked about looking at the paleo archives and seeing, once all of this carbon is put into the atmosphere, how long does it take for ecosystems to go back to normal? How long does it take for the ocean circulation to return to normal? Like, how long does it take for the Earth to naturally bounce back? And we saw that it can take, hundreds to thousands of years. And it all depends on the rate of carbon exchange from these reservoirs. Because the land and the ocean take up carbon relatively rapidly, right? We can see a drastic reduction in carbon just in the next 100 years or so. We can almost have the amount of carbon in our atmosphere just by land and ocean uptake. After about 100 years, though, the land is going to be overwhelmed, right? We talked about that feedback loop where eventually the land just won't be able to take up as much carbon because there's not going to be enough nutrients to sustain that. So eventually the ocean will be the only thing primarily taking up the carbon. That's going to last for 1,000 years or so. And then eventually you get into that really, really long time scale where it starts to match the time scale of rock and mineral weathering, so reaction with calcium carbonate and other silicates. And that'll eventually take down the rest of the carbon, but that's going to be on thousands of years into the future. So the physical biogeochemical carbon cycle in the ocean and on the land will continue to respond over multiple centuries due to the carbon dioxide concentrations created during the 21st century. And the removal of human-emitted CO2 from the atmosphere by natural processes will take a few 100,000 years to eventually go all the way down to normal.